Yes. So then, you know, the last day's night, you received the news the exam has been postponed, right? So, well, I was expecting that, but I was expecting means I know that they are trying to do this because when the educational minister says to postpone the exam, the others they can't change, right? So then, personally, I don't like that postponing case because no need to postpone because most of the students have realized the exam is in December and they have practiced well. But for most of the second choice students and third choice students, they have to manage this, however, to attend to a certain result. So from recollection and all the other results, they have tried to do this again and again. So then, because of them, they have postponed the exam. So that's what I have explained previously also before releasing results. For the second stage students, this will be a big damage, right, when they are releasing results. However, now the exam is on January 23, right? January 23. So actually, we have to reschedule the plans, isn't it? Plans in the reschedule කරන්න තියන්න බෑ. So October 8, 15, 22, 29. November 5, 12, 19, 26. We have December 3, 10, 17. Then we'll do only one class around 21. And after that, we don't do any classes in that year, right? However, we'll do 4 classes. And for January also, right? January 7 and January 14. Around January 7 and January 14, it's better, right? We'll do 2 classes, right? January 21 is also there, but we don't do any class for 21 session, right? So this is what? This is what? So this is 2023 January. And this is 2022 this schedule. Yeah. So how to manage this? First of all, I'll discuss from the first year student side. පළවෙනි පාර කරන ළමයෙක් ගැන හිතලා මම මේක explain කරන්න, right, from my experience. Actually, for a first year student, this postponing case will affect positively and negatively both. Negatively means for a well prepared student, this postponing case will damage or will affect to his age when the results released, university admissions, university graduations, everything will be delayed from 2 or 3 months. 2 or 3 months, right? But nothing to do. The positive case of this is they can prepare furthermore. Okay? They can get ready and they can confirm their results. If you are willing to get an A pass, even you can try for a rank. If you are willing to get a B pass, you can try for a A pass. Likewise, you can. Yes, this is another chance to upgrade your result. You have to think like that. Then you have to work really hard. It is very good now. I will work really hard. This is the time that I have to work. Do not forget, even 2023 students, now they are trying to do 2022 elements. I don't know whether it's possible because admissions are over, but I received many calls from 2023 students. They want to do 2022 elements now because it is in near February, right? January 23 means February first week, like, right? So, but I don't think that will be an option because admissions are over, right? Admissions process is over now, right? So, however, this is a good chance for you, 2022 students. This is how to manage, right? Now, already we have covered the syllabus and we have discussed some papers. 16, 17, 18, 19, 20. So you can get, if you haven't done those, first of all, get those paper discussions from me and then try to watch them again. Right? 16, 17, 18, 19, 20, 20. Right? And then, furthermore, right, we have to do some model papers. Right? So under the model paper category, we have pilot papers, we have term test papers, and we have support seminar papers. The support seminar papers are a bit older, 2015, 16, 14, but pilot papers are very late. I mean, there are latest papers available, and then the term test papers also. So, in my suggestions, right? My suggestions. This is my work plan, right? So, October, November, December, January. So for this January month, I don't charge any class fee from you, right? Because just 2 days, right? No need to charge, but I do the classes. I'm not doing 4 classes because for 1 week I'm doing 2 classes. I'm not deducting that. I'm continuing that, right? I'm going to be වෙනකොට එක week එකකට classes දෙකක් කරනවා. Exam postpone කරනවා කියලා මම ඒක නතර කරන්නේ නැහැ. Definitely I'll do 2 classes for 1 week, right? 2 online classes. So then this is a free month for you. But for the other 3 months, October, November, and December, you have to pay the regular fee, right? Regular fee. So, and then this is the work plan. So how many days available? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So hopefully 14 into 2 would be 28 classes, right? 28 classes at 14 weeks. 14 weeks. You have 14 weeks. I can do 28 classes, right? For my explanations. Right. Okay. Today is October 8th, right? So I'm going to revise theories, right? I'm going to revise theories from different parts. Then after this, what you can do, you can watch short note discussion, right? Short note discussion. Short note discussions, right? So then from that you can modify your short note. And modify your short note within these 2 days. Then අපිට additional time එකක් හම්බුණා. ඒකට අපි additional works කරන්න. Right? Additional we had we have received already nearly 7 weeks. සති 7ක් වැඩිපුර හම්බුණා. Right? Okay. So then after revising the theories, you have to watch the short note discussion. I have all the short note discussions with me: general, inorganic, organic, physical, industry. Okay. So then one short note discussion is around like 2 hours, 2.5 hours. So you have to watch them all within the 2 weeks, right? It's the work plan. And then listen to this one, 22. In this week, what we have to do, 22 and 29, we'll discuss MCQs from 2014 A-levels to 2006 A-levels. MCQs discussion, right? And November 5, we'll discuss structured essay questions from 2014 to 2011, right? That work. And then we will discuss 2021 A-level paper, MCQ, right? MCQ plus structured essay, This is 2021 A-level essay. And then here we can discuss the term test papers. It's a Western province test. Yeah. I'm going to school term test le Western province test again or Abisati again October valeno. At Balan data timetables availability. Abiscold paper again or Abihadane Western province again Hadane Adala Evan. You can always call a time test what? Our time test again Western province. Somehow it's called a time test kill at the eye, somehow it's called a paper cacao on the gun till the day. හරිද ඉස්කෝලේ කැමති නැහැ සමහර ඔය බල බල ඉන්න බෑ එතන ඉතින් මේ ඒ නිසා රොයල් එකේ උනත් දැන් රොයල් එකේ කැම්පස් එකක් තියෙනවනේ ඒතර වෙස්ටර්න් ප්‍රොවින්ස් එකෙන් තව පේපර් එකක් එවුවම ඒගොල්ලෝ වෙස්ටර්න් ප්‍රොවින්ස් එකේ පේපර් එක ළමයින්ට දෙනවා මේක ඔයගොල්ලෝ බලලා ඔයගොල්ලෝ මේ අසිස්ට් මේව කරගන්න සෙමින එකක් වගේ එහෙම කරනවා තියෙනවා කොහොමද අපි වෙස්ටර්න් ප්‍රොවින්ස් පේපර් එක අපි ක්ලාස් එකේ ඩිස්කස් කරමු වෙස්ටර්න් ප්‍රොවින්ස් ඕකේ බලනවා 2022 you schedule කරගමු මෙතන. Then December මේ වෙනකොට time test කියලා ඉවරයි ස්කෝල් වල. රොයල් එකේ දේවි එකේ විශාඛ එකේ මේ අපි 2022 රොයල් ෆයිනල් time test. මේවට දවස් දෙක ගන්න වගේ යනවා. මොකද හොඳට පේපර් එක කතා කරන්න. හරි. රොයල් ෆයිනල් time test එක අපි දවස් දෙකක් තියමු. දේවි එකට එකක් තියෙනවා. 2022 දේවි final term test then අපි class එක 21 කරනවා කිව්වා 2022 විසාකා final term test now again අපි 22 term test class එකේ discuss කරනවා right and then January right I'll discuss 2022 pilot paper and then finally target discussions. This is the schedule. Target stick කතා කරන තැනින් හරිද? ඉතින් මේ අතරදී මම වැඩිපුර ක්ලාස් එකක් තව කරනවා. ඒ දවසේ තමයි මම ඩිස්කස් කරන්නේ practicals ගැන. Right? I will discuss the practicals ගැන. And then I will discuss more live questions. Right? Because I'm doing 2 classes for your batch for 1 week. Right? So you will get 6 hours, nearly 7 hours class time from. Okay, please write this schedule. Product liaga. All these are Saturdays, right? You're from Senasura Davas, Saturdays. So then Friday also we'll discuss another session. Right? We'll have another session apart from this. Right, okay. Have you completed this? Okay, ලියාගෙන මොකද ඔයගොල්ලෝ idea එකක් තියෙනවා මම මොනවද කරන්නේ කියලා. නැත්නම් බලනවා අද මොකද කරන්නේ අම්ම සතේ මොකද කරන්නේ එහෙම හිතනවනේ දැන් දෙයක් නෑ මම මේ ඔක්කොම ලියලා තියෙන ප්‍රෝග්‍රෑම් එකම ටික තමයි කරන්න තියෙන්නේ. Okay, please raise your hands if you have completed this. Let's start the works. Right. ඉතින් ඉතින් අංක හරි. අනිත් අය? I finish? ඉක්මනට කියන්න. Right. හොඳයි. Good. ඔය වගේ plan එකක් දැන් physics වලටත් හදාගන්න. combine වලටත් හදාගන්න. මේ plan එක වෙනස් කරන්න වෙනවා. ඊට බලන්න මේ plan එකේ මොනවද අඩු කියලා. හරි. ඔයගොල්ලන්ට repeat කරන්න තියෙනවා. Past paper writing again 2020, 2019, 2018. මේ papers හතර ආයෙ මේ papers තුන ආයෙ හරි 2019 18 rewrite these papers එකත් මේ plan එක ready කරන්න මොකද rewrite කරා කියලා මම ආයෙත් discuss කරන්න ඕනේ you can rewrite that right these three past papers right we're trying to arrange some sessions physical paper writing sessions also if you are convenient with that please attend to our institutes and you can write papers at our institutes right papers liyanna පුළුවන් right okay that's all then today's point is revising the theories and short note discussions so then within this week I'll be adding short note discussions to you related to organic general inorganic physical and industrial so then try to watch them again section wise and get your short note and try to study it again try to confirm or try to improve the theory background theory ටික තව චුට්ටක් මතක් කරගන්න මම theory වලින් questions අහනවා හරිද in the next week session I'll ask questions from the theory so if you are very convenient if you are confident with your theories you can just give answers very soon right okay right so under the short note discussions we will have organic inorganic physical and general right So let's do some live question discussions related to the theory backgrounds, right? First of all, I'm trying to revise some organic parts, right? Organics. So then under the organic part, if I'm going to do some questions, especially, right? Benzene. A small conversion related to benzene. This and this. Okay. How to do the conversion? What's your answer? Get it now. So disonium salt related conversion. Right. You are any go. Yes, your hands. Muli me berekana pa ekawde. Shanika, Vasan, Akansha, Hari, ekawde. Devanka. Right. That's the time, right? Niru. Good. Mina second. NO2 is a meta reagent. We can attach bromine directly to NO2. Right? According to this conversion. Right? Then keeping NO2, you can attach bromine here like this. Because NO2 is a meta reagent, then simply you have to convert this NO2 to bromine. How to convert NO2 to bromine? NO2 can be converted to NH2. NH2 can be converted to the disonium salts, right? NH2 can be converted to the disonium salts. Then the disonium salt can be directly converted to bromine. Right? Disonium salts bromine කරන්න පුළුවන්. Then මොනවද add කරන්නේ? මෙතන in order to get bromine Br2Fe. Br2Fe, Br3 or Br2Fe. Then this, right? Then here NO2 to NH2. Tin concatenated sodium hydroxide. Tin concatenated sodium hydroxide. Then NH2 to disonium salts. NaNO2 dilute HCl 0 to 5 Celsius. NaNO to dilute HCl 0 to 5 Celsius. Right? The isonames also Br, CuBr. Right? CuBr, HBr, or CuBr. Right? Should be CuBr. Right. That's the conversion. Right. So I'm going to revise aldol condensation. Right? Aldol condensation. So we have self condensation and cross condensation. Right? In conversions we use. So then I'm asking, when you consider this reaction, from the blue color, CH3, CH2, COH, right? With benzene, CO, CH3, right? So you can discuss a self condensation. From self condensation, you get two products, right? Product 1, product 2. So I'm asking, what is the first product in self condensation? What is the second product in self condensation? Furthermore, you can take cross condensation, right? Cross condensation, product 1, product 2, right? So in cross condensation, what is the product? This and then this, right? Okay. So how to start? We should get carbanion from each and every species. What is carbanion? This is carbonyl carbon. The attached carbon is alpha carbon. Carbonyl carbon to ළඟම carbon තමයි alpha carbon. Taking hydrogen එකක් අයින් කරන්න. Right? So then from this, if you are going to get the carbanion from this carbon, you have to remove one of the hydrogens. Then it is CH. Don't write CH3 here. Write it downwards like this and put a lone pair and make this carbon negative. From there, we have to give electrons out. Right? And then this is COH. This is the carbanion of this. Right? මෙයාගේ carbanion එක තමයි මේක. And if you have practiced aldol condensation, what you have to do, right? Then for this species, there are two alpha carbons here and here, but alpha hydrogen is only available at here. Alpha hydrogen තියෙන්නේ මෙතන විතරයි. Right? So then you can remove hydrogen from here, and you will get CH2CO benzene. CH2CO benzene, and then this is minus. Clear? Right. So then because of that, what you have to understand clearly, this is negative charge carbon and this is also negative charge carbon. So this will attack to here and this will attack to here. Likewise, you will get products. What is self-condensation? This one is attacking to this, product 1. This one is attacking to this, product 2. What is cross-condensation? Cross. Right? Cross කියන්නේ cross. This one is attacking to this and this one is attacking to this. Right, write the 4 products. The products විතර ලියලා මට එවන්න බලන්න. Write the products and send it to me. Write the products and send it to me. Right, okay. I'm discussing it, right? So this is the way. So if you consider the first product, the self-condensation, alveolar condensation, this carbon with carbon, so this carbon ion will attack to this, and this bond will dissociate. So this enough to write the alcohol, right? Alcohol is product, right? Then when you do H plus heat, water is released, but no need to get the dehydrated product. This alcohol is enough, right? So how from where we have to start? From the carbon ion, from this? Definitely from this we have to start, right? So when I'm writing here CH3, CH2, then this carbon, this hydrogen you have to put down, bond dissociation O minus, and to that O minus, the hydrogen. Okay? When we make the carbon and that hydrogen is attached, and then in the your right hand side you have CH, this is CH3, and this is COH. Clear? Right. This is the product from the self-condensation. Right? This is the product from the self-condensation. The second product, this one will attack to this. So where the attack is to this and this also. So when you write the product as an experienced student in alveolar condensation or self-condensation, you should know you have to start with the ketone or the aldehyde part, not with the carbon ion, right? Then write this part first, benzene, and then carbon. Put 4 bonds. This CH3 you can put it down like this, and you can dissociate the bond O minus and you get OH. This part you can write CH2 CO benzene. Right. CH2 CO benzene. Clear? Right. So then in the cross condensation, what will happen? The species will attack to this. Right? The species will attack to this. Then you write benzene first. Right? Benzene, then carbon, and put CH3 down. Right? Then OH, the right hand side, write this. Right? CH, CH3, COH. So in a conversion, they will ask one of these. This one will attack to this. Now I'm getting this carbon and is attacking to this. Cross, right? Start with this. CH3, CH2, and C. මේ එක්ක ලියන්න පල්ලෙහායි. මේ එක. මේ බොන්ඩ් එක dissociate වෙනවා. O minus. O minus එකට H එක එන්නේ මෙතන. හරි. දැන් ඉස්සර CH3 හිටියේ. CH3 වලින් H plus එකක් ගියා. H plus එක තමයි මෙතන. Right. Then මෙයා මෙතන attack කරනවා CH2CO. If you do H plus heat, like H plus, හරි. H plus heat එකක් දැම්මොත් මොකද වෙන්නේ? This OH will be removed with one of the hydrogens either sides. පැත්තෙන hydrogen දෙන කෙනෙක් එක අයින් වෙනවා. Right? One of the convenient hydrogens will be removed. So then, so this hydrogen or this hydrogen, any hydrogen you can take. There's an effect from benzene also. Right? However, is it clear the products? Right? Please raise your hand if this is clear to you and your answers are correct. Right? Good. Yes. And our class students will get another chance. You can watch our past recordings for any lesson if you want without paying for them. Right? Just get the sessions from us. We are sending it as a private email to you. So then try to watch those lessons if you want to watch kinetics or inorganic or unit 2 or unit 3, right? Unit 11, unit 12, any lesson. Okay? If you are a past student of us, right, well-known past students of us in our classes, definitely we will not charge from you, and we will be giving all the sessions as free sessions to watch. Because now you know you have the time, you can do some more work, so then it is better to watch some sessions, especially ionic equilibrium if you want, kinetics, right, isomerism, then mechanisms. So when you want to recall the theories, so if you wish, that would be better. That's up to you, right? So then you can just get it. So I'm trying to do random questions from here and there, and I'm trying to arise every part in the syllabus like this. Clear? Okay. Yes. This is an organic nomenclature question, right? I'm going to give an organic nomenclature question to you. Let's try to do your best. CH3 O CO CBr H CH2 CN. What's your answer? Try to get it. Write the question and write the name. It's an organic division at the beginning, right? What is organic division එකක් කියන්නේ? At the two names. Right, okay. What is the answer? The first one is an ester, right? It's an ester. So when you're writing an ester, the name is a special name, right? You have to write the name of this group first. This is methyl. And then you have to keep a space. And then you have to start squaring the carbon chain. Carbon chain is square karanna. So for your carbon chain, you have to get the highest number of carbons, right? Highest number of carbons, including carbon-carbon double bonds. But you know now, this is bromo and this is cyano because the main functional group is this, right? We're not supposed to get cyanide as the main functional group. Then cyano is a subgroup. When cyano is a subgroup, we have to keep it outwards the main carbon chain. Main carbon chain එකෙන් එළිය තිබ්බොත් තමයි subgroup එකක් වෙන්නේ. If you are taking this carbon to the main carbon chain, that would become a main group, right? Main group. So then this is the nature of the subgroup. Right? Nature of the subgroup. This notation. Let's understand. And then right. Then we have to write the name. This is bromo. This is cyano. And we have number 1, 2, 3. Don't say 4. 1, 2, 3. So it is 2 bromo, 3 cyano, 3 carbons. So there is propan. Okay. This is OH. Propan 1 OH or propanoid. Because there's no carbon-carbon double. For this one, you can rewrite the name.Onna make a structure can balance. OH means COO. Then methyl means this is CH3. Then prop means 3 carbons. 1, 2, 3. Then 2 bromo. 2 volta bromo. 3 volta cyano. 3 volta cyano. ඉතුරු ටිකට hydrogen නේ 1 2 3 4 right 1 2 3 this is how we create ඒ වගේ depth එකක් තියෙන answer එකක් තියෙනවා නම් backwards name making structure එක අඳින්න පුළුවන් වෙනවා structure එකේ name එක වගේම name making structure is it clear any questions please raise your hand if that is clear right okay what is this it's a carboxylic acid right from here you can just get the largest carbon chain including this so this is cyano this is phenyl this is not formyl the aldehyde එකක් නෙවෙයි because carbon is included to the main carbon chain this is an aldehyde the aldehyde group එකක් වෙනවනම් it can't be available at the edge එකට එන්න බෑ right already carbon is available in the main carbon so then only oxo or the oxygen is the subgroup. So when oxygen is the subgroup, we say it's oxo. Right? This thing here you have aldehyde. Right? When this thing, this is forming. From carbon, oxygen, hydrogen, all the 3 atoms are outwards the main carbon chain. This is formyl. Right? This is formyl. This is oxo. Oxo. So you know the difference. Right? Know the difference between them. And then CH is oxo, this phenyl, and this is cyano. Right, let's try the name. 1, 2, 3, 4, 5, 6. Which one we have right first? I think cyano. For cyano, Don't say cyanide, right? It's inorganic. This is 6-oxo. And A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. OP. 6-oxo 3-phenyl. Carbons 6. ඒ කියන්නේ hex. Double bond එකක් තියෙනවා මෙතනනේ. තියෙනවනේ නෑ. Double bonds නෑ. Right? ඒ කියන්නේ hex and double bonds නැත්තම් එහෙමයි යන්නේ. hex and last E එක ලියන්නේ නෑ. හරි. oic acid එක place කරනවා. One oic acid. There should be a gap here. Right? Is it clear? Any issues? මොනවද ප්‍රශ්න තියෙනවද පසන්? Yes. ඖෂධ. අභි එපා is it clear? සර් ෆෙනිල් කියලා ලියන්න බැරිද? මම මොකද ලියන්නේ? ෆෙනිල් කියලා නේද ලියන්නේ? ෆෙනිල් කියලා ගන්න බැරිද? ඒ ෆෙනිල් කියලා තමයි ගත්තේ. වෙන මොකක් හරි ගත්තා. බෙන්සිල් කියලා ගන්නේ නැහැ. ගන්න බැරිද නෙමෙයි ගන්නේ නැහැ ඒක. එක්සෑම් එකේ ගන්නේ නැහැ. ෆෙනිල් කියලා තමයි මේකට කියන්නේ. බෙන්සිල් කියලා කියනවා මම දැකලා නැහැ. ඒ නිසා ගන්න එපා. ගත්තා කියලා වැරද්දක් නැහැ ඉතින්. ෆෙනිල් කියලා තමයි most common use වෙන්නේ. Right. Is it clear? Okay. Any මොනවා හරි issues තියෙනවා මේ වෙලාවේ යන්න. Right. Hi, Liane. Organic nomenclature. I'm going to go get an organic mechanism question right now. Right? Organic mechanisms. Organic night ඔක්කොම device වෙන්න එපානේ. මේ organic mechanisms. So let's consider this CH3, CH2C, CH2, CH3, CHBr. You have to treat this one with CH3, CH2, O, minus. CH3, CH2, O minus. This when this is acting as a nucleophile, you have write the product. When this is acting as a base, there are dual functions for this, right? Dual functions available for this. You have to when this is acting as a base, you have to write the product, not only the product but also the mechanism. Write the product with mechanism. Write the product with mechanism. We put another CH3. I have made this one a tertiary alkyl halide. Right? So I'm asking nucleophilic substitution plus elimination reactions now. Right? It's a common case in a level exam. Nucleophilic substitution plus elimination. Write the products and the mechanism. What is nucleophile? Attacking to positive charged carbons. What is a base? A base means gaining H plus. Right? So you can get your organic note and turn your organic note if you are uncomfortable with your theories. Right? And then you can turn nucleophilic substitution reactions. Right? Under that, we have written these reactions SN1, SN2. So then you can write the products. Okay, I'm going to reveal the answers, right? So this is the way. First of all, I'll mention acting as a nucleophile, right? When this is acting as a nucleophile, definitely there's a two-step mechanism occur, because this is a tertiary alcohol. When you remove bromine from tertiary alcohol, when this bromine is removed, you can see this carbon, and then it will become positively charged. So this is called a tertiary carbocation, right? So we know clearly tertiary carbocations are very stable compared to the primary and secondary. So since the tertiary carbocations are really stable in that case, when you remove bromine and then this species is willing to attach, it's easily attached here, right? So then there's a two-step mechanism. Okay, two-step when because the stability of the carbocation. As the carbocation is stable, before this one attacks, bromine is dissociated. Then you get the carbocation. And for that carbocation, this species is attacking, right? Then this is two-step version, right? Nucleophilic substitution will occur in two steps. In which case we get one step when the carbocation is unstable, right? Specifically, when you get the primary carbocation, it's a kind of an unstable carbocation, right? So in this one, CH3, CH2, CH3, CH2, CH3, right? First of all, we remove this bromine, right? Delta plus delta minus, complete arrow, right? Then you get CH3, this is CH2, CH3, and here CH2, CH3. You get positively charged and bromine Br minus. And you can take the carbocation here, right? CH3, CH2, C, CH3, CH2, CH2. Positively charged, right? Then for the positively charged carbocation, this nucleophile, and then come a nucleophile again, or CH2, CH2. This one is willing to attack the positively charged carbocation. The product you get, right? From this, you will get the product CH3, CH2, C, CH3, and here CH2, CH3 plus this part, right? Or CH2, CH. Okay. So this is first step. This is second step, right? Nucleophilic substitution in two steps. Is it clear? I have used these arrows, right? Always when you put the arrows, you are putting the arrows from high electron density to low electron density. Right? So take that one. And then when this species is acting as a base, can the nucleophilic accept alcoholic pH do elimination? Yes. Elimination එක කරන alcoholic pH කියලා alcohol කියලා medium එකක් ඕනේ. Alcohol aqueous කියන medium එක කියන්න ඕනේ නැහැ. In mechanism questions they are only giving the species OH minus. So we know OH minus can act as a nucleophile as well as a base, right? OCH2CH3 can act as a nucleophile as well as a base. C triple bond CH. තව දෙයක් species ඕන. C triple bond C CH3. This can act as a good nucleophile as well as a base, right? ඒ වගේ වෙයිදී medium එක sure එකක් නැහැ. In mechanism questions they will ask what is the major product. So then that most of the times that could be nucleophilic substitution. They are asking apart from the major product, there's another product. What is that and what is the kind of mechanism? So definitely that is elimination, the mechanism type, and the product is the next product after the elimination, right? So in alcoholic medium, the elimination is, preferred, favored. In aqueous medium, substitution is favored. But in a mechanism question, if remember you have major products and minor products. So then it is up to you to write all the products as possible and mention the probabilities of death as major and minor. Yeah, because it's a mechanism question, it's not a conversion question. In a conversion, you mention only the major product. But in a mechanism, you have to explain all the products and the method how we have taken, right? Okay. I'm going to write how it acts as a base at this moment. Base එකක් විදිහට act කරන එක මීට වැඩිය අමාරුයි. හරි? මම ගිලස් කරනවා. මෙතනින් එන්නේ ඊට එකක්. Right? Ether is produced. Sometimes they are giving the ether and asking you the steps. මේ ether එක දීලා අහනවා මොනවෙන්ද ether එක හැදෙන්නේ කියලා. Backwards. Right? Now see this one. And take this C, Br, CH2, CH3, CH3. This is CH2, CH3. Right. So C triple bond C, given O CH2 CH2. මේ කොහොමද nuclear file එක මේ base එකක් විදිහට act කරන්නේ, right? When this species is acting as a base, it is gaining H plus. From where it is gaining H plus? You know, bromine attached carbon. Bromine attached carbon ගෙන්ද ගන්නේ නෑ. එයාට adjacent carbon. දැන් මෙයාට adjacent carbon ලා 3 දෙනෙක් ඉන්නවා. Right? Bromine attached carbon is having 3 adjacent carbons. 1, 2, 3. Which one we have to select? The carbon with lowest number of hydrogens. Hydrogen යනකොට යන්නේ hydrogen අඩුවෙන් ඉන්න carbon. Hydrogen එනකොට එන්නේ hydrogen වැඩියෙන් ඉන්න carbon ගාව. නේද? Markovnikov law says that. So you can remove any hydrogen from these two. මේ දෙන්නකින් ඕන කෙනෙක් remove කරගන්න ඒක ප්‍රශ්නයක් නෑ දෙන්නම same. හරි කොහොමද remove වෙන්නේ? ඔන්න අපිට බලාගන්න. This is the mechanism. I'm trying to expand this and go. Make expand කළාද? Bromine attached carbons, adjacent carbons, hydrogen is removed. What? Bromine attached carbons, adjacent carbons, hydrogen is removed. So in which hydrogen is attacked? Lone pair के कोई hydrogen attack करन. इनमें दिलंगे कारण है तमें. This lone pair is given to one of these hydrogen. Then what will happen? This hydrogen will be removed as H plus, and then you know the electrons available in this bond, these are given to here, right? This is number 1, and these electrons are given to here, number 2. And then the CBr bond, these electrons are dissociating like this. Right? One no electrons become dissociate here. Here, dissociate. So CH3, CH2. CH3, CH2, C, right? CH3, CH3, yeah. So this hydrogen is removed, right? This hydrogen is removed. Then here between this carbon and this carbon, you have a double bond. So this is the 2 carbons, right? This carbon is here. Carbon is here. This hydrogen we have to place here. Carbon is attached to another carbon, which is having CH3. And can you understand? This species is acting as a base. Acting as a base means gaining H plus. Base එක function එක තමයි H plus ගන්න. Right? So you are gaining H plus. So then here this hydrogen is gained towards this direction. These electrons are given to here, and we get a double bond there. And then as this carbon is gaining electrons, it is leaving electrons from bromine. The bromine common carbon gaining electrons in the The carbon take a prashna. Carbon is willing to give electrons to bromine when carbon is gaining electrons from this direction. Right? That's the third choice. 1, 2, 3. Is it clear? Just raise your hands. Elimination reaction එක alcoholic medium එක තමයි. මේක mechanism එකේදී medium එකක් ඕනේ. In the mechanism, they won't ask any medium. If you have the species, the same species can act as a base and a nucleophile and form the 2 products. Don't think about the medium. But in alcoholic medium, this is preferred, right? I mean favored. Alcoholic medium එක elimination එක තමයි favored. You get an alkene after the removal of HBr in the alcoholic medium. But if you have aqueous medium, due to the polar conditions, this will undergo a nucleophilic substitution reaction. Right? එහෙම දෙයක් වෙන්න පුළුවන්. මේකට නම් alcoholic medium එකක් දැන් එකක් නෑ මොකද මේක මේ OH එකක් alcohol එකක් නෙවෙයිනේ. C3H2O minus Na plus වගේ වෙන alcohol එකකට sodium වගේ දාන්න. alcohol එක sodium එක react වෙලා තියෙනවා. sodium alkoxide, sodium ethoxide. Right, okay. අපි තව mechanism එකක් ලියමු. ඒක ගොඩක් දවස්වල අපි mechanisms ලියන්නේ නේද? තව හොඳ mechanism එකක් ලියමු. මේක හදාගන්න issues ටික. Right. The next mechanism is this. Benzene, CH3. You have to add conc HNO3, conc H2SO4. Right? That means you have to do the nitration. So when you do the nitration for this, you perform the nitration. Since this is an orthopara reagent, NO2 group will be attached to the ortho portions of the para portion. So then you will get two products. Actually, you will get two products. CH3 is attaching to here, so NO2 is attaching to here, and NO2 is attaching to here. CH3, NO2. Okay. Try to explain this product using the mechanism. I give this product as B, then explain the formation of product B. First of all, you have to write how NO2 plus is formed, which is the active species here. Then you have to attack it to benzene and write. You can't use this structure, I mean the resonance structure. You have resonance hybrid. You have to use the Kekulé structure for benzene and explain the mechanism. Okay, explain the product B using its mechanism. I'll give 2 minutes. Start doing it. Organic mechanisms, benzene, nitration. Okay. So then these are the answers here. Right? First of all, you have to react sulfuric with nitric. Right? H2SO4 sulfuric H2SO4 will react with HNO3. HNO3. So which one is the acid? Sulfuric is the acid. This will release H plus and nitric will gain. Right? So when you write nitric, you have write OH NO2. Normally, sulfuric right? In this format, OH SO3H, right? H2SO4. And this is acting as a base. This one is acting as an acid. So acid is acting as a acid. This will release this hydrogen, right? I mean, sulfuric is liberating H plus. Nitric is accepting H plus, right? Nitric is accepting, sulfuric is liberating. Then you can put this arrow to here, right? And then this bond get dissociated. Right? This OH bond get dissociated to oxygen. So what is the product, right? What is the product? From here you get HO, again H, this oxygen is positive, and NO2, and then we have HSO4 minus. HSO4 minus, right? So then what we do, this is unstable, right? This is unstable. So this has to be stabilized. It has to be stabilized, so then it will gain electron. This oxygen is positively charged, so then this is gaining electron from nitrogen, and there's a rearrangement. So you get water, NO2 plus HSO4 minus. So actually NO2 plus is the active species. NO2 plus is the active species. And then you can write methyl benzene, CH3, right? You put here, here, and here. So then write NO2 plus. Always write HSO4 minus with that. So you are supposed to get this product, right? NO2 should be attached to here. So then if product if NO2 is attached to here, NO2 is plus, so then this should be delta minus. Then this should be either delta plus. You understand? Right? When we attach NO2 to this location, NO2 is positively charged, so then this location should be negative. And the carbon which is attached to this carbon as a double bond should have a positive charge, right? So what you have to realize, this bond is dissociated towards this. Towards this way the bond is dissociated, right? And then this NO2 is attached to positive charge, NO2 is attached to the negative charge carbon. So from here, benzene, okay, CH3, this NO2 is attached to the negative charge carbon here, right? There, and here we have the bond, this bond, right? And here you have to mention another hydrogen, and that's positively charged carbon. Right? And carbon is having 3 bonds, we say that's a positive charge. We say that's a positive charge. Right, okay. Then what we have to do? Right? Then we have to rotate the positive charge. They're asking, we have to show that. They're asking the resonance stabilization. Unless we can get the final product now. Final product, right? So then we can start with this in the next line. Benzene, CH3, NO2, H. Right? This is positively charged. Then what you can do, You can put HSFO minus, right? HSFO minus is willing to give out electrons. So this HSFO minus, this oxygen, is acting as a base and attacking to this hydrogen and gaining hydrogens from that, right? And then these electrons in this bond given to this, given to here, right? Given to here, and then next the double bond, right? Then you can write the final product from there. Benzene, CH3, benzene, another one, you get NO2 attached to the para location, and then release H2SO. Right? So this is an electrophilic substitution mechanism. And the active species is NO2 plus. Okay? Better to mention them also. Active species is NO2 plus. Is it there? Raise your hand if this is clear. If there's any issues, ask for me. Right. So this is benzene nitration. Right. So then I discussed two important mechanisms related to this. Right. Let's go to inorganics. Product session right. The revision side, I'm moving to inorganic revision, inorganic plus industrial revision at this moment, because you have to watch short note discussions after this: organic, inorganic, industrial, physical, and general. Right. I will add them. Please join with our groups, okay? And then you will be getting them. Right. Great. This is right. Mechanisms ලියලා පුරුදු නාම තමයි mechanisms ලියන්න ආසී. Mechanism පාඩම් කරන්න බෑ. We have to write and understand, right? Right. Write the colors of the following species. The question is this, right? Write the colors for following species. Write the colors for following species. The question is, write the colors for the following species. Right. I'm going to give some species to you. You have to write the colors. Here. Right. One, AgCl, Ag2Cl2, PbCl2. These are precipitates, right? PbS, CuS, HgS, Bi2S3, CdS, As2S3, Sb2S3, SNS, SNS2, write with me, write the diagram. ALOH thrice, FPOH thrice, CROH thrice, COS, NIS, MNS, zinc sulfide, FPS, SrCO3, CaCO3, BaCO3, right? KFe, FPCN6, 23, 24, Cr3 plus aqueous, 25, Mn2 plus aqueous, Fp3 plus aqueous, nickel 2 plus aqueous, Fp2 plus aqueous, zinc 2 plus aqueous, copper plus aqueous, copper 2 plus aqueous, CrNa3 6 times 3 plus, CONa3 6 times 2 plus, CONa3 6 times 3 plus, NiNH3 6 times 2 plus. Right, and mention the color. Is it in Na3 6 times 2 plus, CrCl4 minus, MnCl4 2 minus, FpCl4 minus, COCl4 2 minus, COOH4 2 minus, CuCl4 2 minus, NiCl4 2 minus, Ag Na3 twice plus, CrO4 2 minus, Cr2O7 2 minus. Right. MnO4 minus, MnO4 2 minus, MnO2, MnO2. Question number 50, right here. Okay, I can write here 50 Fp FCN 2 plus. There are 50 colors I have written in the board. I can add a photo of this to your WhatsApp group. Please write as you know. Then we did a pencil and the colors. Right? And we can just check it now. Then, please write it now. Right, okay. Have discuss karamena. So I'm going to give the colors with the answers for this, right? So I'm using your inorganic research book also for this discussion, as that's a detailed discussion. And then these are the colors actually you have to keep remember in your mind. Directly these colors will be useful for your MCQs and inorganic essay question, right? Both MCQs and inorganic essay questions. These colors will be very useful. Okay. So then these are the answers for the colors. Silver chloride, it's a white color precipitate. White color precipitate. Mercurous chloride, white color. Lead chloride, white color. Check answer. Lead sulfide, black color. Copper sulfide, black color. Group analysis order තමයි ලියලා තියෙන්නේ. Mercuric sulfide, black color. Bismuth sulfide, black color. Cadmium sulfide, arsenic sulfide, Sb2S3 and SNS. So Sb2S3 up to here. Cadmium sulfide, arsenic sulfide. Made in a yellow color. Sb2S3 is orange color. SNS2 is yellow color. SNS is brown color. Brown color. Any issues? Have you checked that? Right, next one. Aluminum hydroxide, white color. Ferric hydroxide, dirty green color. Chromic hydroxide, ferric hydroxide, yellow brown color. Ferric hydroxide, yellow brown color. Chromic hydroxide, dirty green color. Cobalt sulfide, nickel sulfide, black color. Manganese sulfide, pink color. Zinc sulfide, white color. Right? Pink color, white color. Ferrous sulfide, black color. Strontium, calcium, barium, white color. And this one, KFP, FeCN6. This is Prussian blue. Okay? Prussian blue color. Prussian blue color. Prussian blue color. Then Cr3 plus aqueous, purple color. Mn2 plus pink color. Fe3 plus yellow brown color. Nickel 2 plus green color. Fe2 plus green color. Zinc sulfide, zinc 2 plus colorless. Copper plus colorless. Copper 2 plus blue color. Cr Na363 plus purple color. Okay, purple with yellow. Purple and yellow. Cobalt, hexamine, yellow brown color. This is orange brown color. Nickel blue color. Cobalt, hexamine yellow brown color 2 plus. Okay. When you move to 3 plus, it is orange brown. Right. Nickel, hexamine, blue color. Right. Blue color. And then when you consider zinc amine complex, the amine complex with zinc, that is colorless. Colorless. Right. Colorless. Check the chlorocomplexes from the research book because the colors are sometimes changed from one book to another book. So then chlorocomplexes become a research book. Related to chromium, the chlorocomplex is this one, CrCl63 minus, blue violet. Manganese, greenish yellow. Fe3 plus, FeCl4 minus. Cobalt, CoCl2 minus. Okay, next one. The chlorocomplex here, these three. NiCl4 2 minus, CuCl4 2 minus, and NCl4 2 minus. Right. At the same time, you can see cobalt with excess sodium hydroxide forms the deep blue hydroxy complex. An exception, right? Cobalt is not an amphoteric one. Dark blue color, the Prussian blue color, we have the colors. Research booking අපිට බලන්න පුළුවන්. එකක් Tannenberg blue අනිත් එක Prussian blue. Right. Right. So then after this, related to Fe, the colors, two colors here. Right. This is dark blue precipitate. This is dark blue. And you get this one. Prussian blue. Prussian blue. Yeah, write the two colors of this. That will be useful. Okay. So now after that, diamine, silavanna and colors. Right? Diamine, silavanna is colors. Chromate, yellow color. Dichromate, orange color. MnO4 minus purple color. MnO4 2 minus green color. MnO2 a black brown color precipitate. MnO2 a black brown color precipitate. Okay. 49. Finally 50. It is available here. FeSCN2 plus dark red, blood red, right? FeSCN2 plus dark red or black blood red. Okay. That's the color. Blood red color. Right, okay. I'm going to erase this. So out of 50, you can put your marks if you want, right? For the colors exercise, the 50, you can put your marks. Likewise, when you write all the colors at one single question, that's very good because you can see what are the species with same color, and then you can easily keep them in one single group, and then remember easily in your mind, right? Because they are available in one single group. So the blue color when I right? Likewise, try to do some categorizations, right? I mean separations, and you can easily keep the colors in your mind. Okay, next thing is graphs. Put a graphs revision එකක් කරන්න හදන්න. Graphs. Draw the follow given graphs according to the requirements. Draw the follow given graphs according to the requirements. Right. Draw the graphs for these versions. Is physical chemistry. Physical chemistry. Number 1. So then when you consider unit 1 atomic structure, what are the graphs you get? Right? You get the ionization energy graphs, basically. Then there are graphs with radius, electronegativity. Right? So now I'll give one graph. You can draw the variation of I3 with atomic number. Atomic number for the second period and third period. Right? For the second period and third period, draw the variation of I3. Which one is highest, which one is lowest. Right? In unit 2, we don't get any specific graphs. Right? The 2 and graph in ahead. When we come to unit 3 also, we get more equations, but there's no proper graphs. But in unit 4, we have many more graphs. P with V, right? P with 1 over V. PV with V. V with T, temperature is in Kelvin, right? And here V with T, temperature is in Celsius, V with T. Fourth one, can get the speed of molecules, and here number of molecules, right? Molecules. So you can plot the variation with temperature T1, T2. T2 is higher. Molar mass M1, M2. Molar mass එකත් එක්ක plot කරන්න පුළුවන්. Then you can plot the phase diagram. Right? You can plot the phase diagram. You have to mark the solid, liquid, gas, and then these axes, and then triple point, boiling point, critical temperature, critical pressure. These ones you can mark, right, in your graph. Then you can draw an enthalpy level diagram for exothermic reactions. Mark the activation energy for the forward reaction, activation energy for the backward reaction, and then delta H, right? This thing A plus B is converted into C. Here you have to mark that stuff. And then furthermore, can get the delta G curve, right? The delta G curve like this. Right. Delta G curve, right? So you have to mark delta G plus, delta G minus, delta G 0, right? Delta G 0 on this, and mark reactants and products, right? Reactants and products, right? Write the relationship between QC, KC. QC, KC relationship they know. Okay. තව graphs ගොඩක් තියෙනවා මේ board එකේ ඩීලේ ඉවර කරන්න බෑ මොකද මේ ටික ලියලා ඊපස්සේ ළඟ ස්ටේජ් එක ආයි ළඟ කතා කරමු නේද මේ ටික ඔයාලා ඉවරට පස්සේ ළඟට කතා කරමු right. First of all, plot these graphs. Okay. First of all, plot these graphs. Always when you are plotting the graphs, name the axis. Name the axis first, and then plot your data well, right? Data හරියට plot කරන්න. And then think of your units. Axis name කරපු ගමන් axis වලට units දාන්න හරියට. Celsius ද Kelvin ද Pascal ද හරි. ඒ ටික මාක් කරගන්න. ඊට පස්සේ හොඳට data ටික plot කරන්න graph එක ගොඩක් label. After this මම තව දෙන්නම් ඔයගොල්ලන්ට diagrams mark කරගන්න. Okay, start doing this graphs exercise. Right, okay, we'll discuss. Now here, I asked I3. So when you can draw the variation, there is 2, 3, 3, right? 2, 3, 3. In the third ionization energy, right? Here 2 elements, here 3 elements, and here 3 elements. Generally, in one single period, there are 8 elements. So from those 8 elements, this is the variation. In the third ionization energy, specifically, you have to keep remember, we are starting the third ionization energy with group 3 elements. So we know group 1 element is lithium, group 2 element is beryllium, group 3 element is boron, right? So you have to write boron here. Boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. Then beryllium will be having the highest second ionization, lithium will be here. And then again, when you get aluminium, you will move to here. Then another 2, 3, 3 you can do, right? 2, 3, 3. This is 2, 3, 3. Then after aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Okay. That is how the variation you have to get. මේ variation එකක් තමයි අපිට ගන්න. So then P with V, you know Boyle's law, right? This kind of a graph. P with 1 over V, this kind of a graph. PV with V, okay, a linear graph. V with T in kelvins, this kind of a graph. But V with T in Celsius, you have to get this kind of a graph. Right? Y equal to mx plus c. When you extrapolate this here, you will be getting it in at minus 273 Celsius, right? Minus 273 Celsius. This is a phase diagram, right? This solid, liquid, and gas. This is critical point. This is triple point. So you can mark triple. This is temperature. This one is pressure. So this is critical temperature, and this is critical pressure. Critical pressure. This is triple point. Then this is the triple point's temperature. This is the triple point's pressure. This is a melting point. I have to mark melting point in between solid and liquid. Let's understand. You have to mark the atmospheric pressure as 180. So then for 180 m, if you are getting a certain point equilibrium between solid to liquid at 180 m, that is called melting point. Then liquid and gas, if you are getting an equilibrium at 180 m, it is boiling point. Right? Boiling. Can 180 m එකේ තමයි liquid එකක් vapor වෙන්නේ. So when the liquid is converted to vapor, if the saturated vapor pressure, if the pressure of the system is equal to the atmospheric pressure, we say it's boiling point. Right? We say it's boiling point. Okay. Furthermore, you can mark the activation energies like this. This is the activation energy for the forward reaction, AE forward. This is the activation energy for the backward reaction. And then the gap between this is called delta H. The gap between this is called delta H. Right. And then the speed Maxwell-Boltzmann distribution curve moves like this, right? And when you increase the temperature, this curve shifts right hand side at T2. But you have to decrease the molar mass. In order to shift the curve to your right hand side, you have to decrease the molar mass. So this should be M1 over molar mass. This should be M2. Right? In the delta G curve, this is the Gibbs energy. This also Gibbs energy. Here we have reactants, 100% reactants. Here we have products, 100% products. Right? At a point like this, we say delta G is 0. In that point, QC should be equal to KC. Delta G can make a gradient. So මේ වගේ point එකක gradient එක 0 වෙනවා. Gradient එක 0 වෙනවා. බලන්න මගේ delta G explanations chemical equivalent එක අරගෙන. Delta G 0 කියලා කියන්නේ QC equal to KC. Right? QC equal to KC. So when you get a point like this, This is delta G negative. What is delta G negative? It is a spontaneous reaction. Okay. Why the spontaneous reaction? The forward reaction is feasible. So reactants are converted into products. More and more reactants are converted into products. Why? The amount of products are low at the beginning. That means we should understand here QC is lower than KC. And QC එක KC ට වැඩි අඩුයි. QC අඩුයි කියන්නේ නැත්නම් products අඩුයි. So then system is trying to increase the products. In order to increase the products, the forward reaction is favored. That's what we say delta G is minus. Right? We can mark all the 3 points. Delta G minus, delta G 0, delta G plus. Right? Delta G plus. This kind of a point is delta G plus. Right? Delta G plus non-spontaneous. I think the reaction is A to B. Right? It will not take place because the gradient is positive. Right? In this case, QC should be higher than KC. Right? QC should be higher than KC. මේ ගැන මම ගොඩාක් explanations කතා කරලා තියෙනවා අපේ equation lesson එකේ. Right? Equation lesson එකේ. So I'm going to draw another graphs related to your syllabus. So already I have drawn 7. Right? Then I'm going to draw more. So then let's get the next slide. So you can mark this information, right? You can mark this information and get it. So this is compressibility factor, right? Compressibility with factor with pressure for gases helium, CO2, CH4. Right? You can draw the graphs. And then again compressibility factor with pressure for H2 gas at these temperatures 200 Celsius, 400 Celsius and 900 Celsius. Right? When the temperature is changed, how the graph is changed. Okay? Mark the ideal gas also. Mark the ideal gas also. With respect to ideal, you have to mark. And then you have to draw the variation. Right? This is 8. You have to draw the variation of the saturated vapor pressure. Okay. Vapor pressure versus composition for a mixture of A and B. Right? A and B, here A is XA is 0 and here XA is 1. Right? So this is when the interactions are same, this is ideal behavior. Right? So when ideal behavior is there, how the boiling point, the temperature versus combustion, right? Whether I become XB here, XB0, XB1, how this is varied, right? For ideal cases. This, and then I'll ask in this situation when FAA, FBB, FAB. Okay. In this situation, F means forces, right? You have to plot the graph again. You have to plot the graph again. Vapor pressure versus combustion. Here XA equal to 0. Here XA equal to 1. Boiling point versus combustion. Boiling point versus combustion. XB equal to 0. XB equal to 1. Okay. Try to draw these 4 graphs. 1, 2, 3, 4, 5, 6. Then graph half in. I'm on one of the questions. Right. So can you please explain compressibility factor graph? Method graph. So try to draw it. Okay. It's a small size. Size එක graph එක අනින්. ඒ syllabus එකේ තියෙන හැම graph එකක්ම touch කරා නම් හරිය resource book එක බලන්න. හරි. මම මේකේ basic graphs ටික තමයි මේ ගොඩක් පෙන්නන්නේ. ඊට තියෙනවා pH curves. එහෙනම් ඔය graph නේ. electrochemistry වල සමහර graphs තියෙනවා. Right. Those are also really important. Okay. Right, okay, we can discuss the graphs. First of all, compressibility factor with pressure, right? Compressibility factor means PV over NRT ratio. PV over NRT ratio. So, for ideal gas, this is 1.0. Ideal gas is 1.0. And then we know hydrogen gas is the most closest gas to the ideal behavior. Ideal behavior is close when hydrogen gas, H2 gas. So we have to mark it, okay, like this. Hydrogen hydrogen gas mark helium. Moving very close to the ideal behavior. When you increase the molar mass, when you increase the molar mass, the amount of attractions will get increased. Higher the molar mass, higher the amount of London forces. So as the attractions get increased, they are deviating from the ideal behavior. Right? So they are deviating from the ideal behavior. So then this is CH4, this is CO2. Right? These curves can be changed, if you remember, according to the pressure, right, and temperature. And make it a temperature, we have to keep all these in constant temperature. But when you change the temperature, the curves will change, right? So in different books, there are different arrangements available depending on the temperature, right? You can search in the internet also, so you get some curves, right? Sometimes this CO2 is coming upwards than methane, likewise. Generally, when you increase the mass, this curve is moving downwards, right? There's a downward trend, and then again it increases. So in your research book, they are clearly mentioning why this is moving downwards and why this is moving upwards, right? As the amounts of attractions are increased than the repulsions, at a certain time this is moving downwards, deviating, and then amount of repulsions are greater than the attractions, this is coming up. So then you can see why Z is less than 1 and why Z is greater than 1. Z එක 1 වලට වැඩි අඩු වෙන්න වැඩි වෙන්න දෙකම reasons research book එකේ තියෙනවා. හරි. බලන්න. And here you can mark ideal behavior again 1.0 for ideal gas, and then for hydrogen gas you have to draw the plot for 3 different temperatures, 200, 400 and 900. We know at 200 Celsius, right? When you increase the temperature, make a graph under pressure, right? When you increase the temperature, it attains the ideal behavior. That at 900 Celsius, it behaves as a good ideal gas. 900 Celsius. And 400, 200, deviating from the ideal behavior. Right? 400, 200. Can temperature deviate. Likewise, you can show some deviation. Higher the ideal behavior, when you increase the temperature, it shows a good ideal behavior. Ideal behavior means the curve is moving through at 1.0 line. So these are ideal solutions. Ideal solutions means before mixing and after mixing, the amount of interactions are same. If you get ideal gases, that means the amount of attractions are negligible. The amount of interactions are negligible, and then there are gases which act as point masses. Right? There's a mass, but there's no volume. Right? That is called ideal gases. So in ideal solutions, the amount of attractions are same before and after mixing. So then if we draw this plot, if we get make up boiling point just mark it. XA1 means here you have to mark P0A. Right? So when XA1, here this is XB0. This is XB1. So at XB1 you have to mark P0B. You can mark P0B upwards or downwards. But if they are giving the saturated vapor pressure of A is high, this should be here and B should be here. If they are giving saturated vapor pressure of B is high, okay, according to that you have to draw the plot. However, this is the partial pressure, the variation of the partial pressure. And this is the variation of the partial pressure for B. And then this is total pressure. The variation for the total pressure. Okay. Variation for the partial pressure, variation for the partial pressure of A, variation for the partial pressure of B, and variation for the partial pressure of T, the total pressure. See there? That's the point. And then it is xb equal to 1, right? xb equal to 1 is xa equal to 0, then xa equal to 1. Then temperature, no? So then xb equal to 1. You know clearly now here, according to my setup, P naught B is lower than P naught A. P naught A, P naught B adui කියලා කියන්නේ boiling point. The boiling point of B is higher. T naught B is higher than T naught A. T naught B is higher than T naught A. So you can mark the plot, right? Just we are marking like this. Now try mark. This is the liquid zone, this is the vapor zone, this liquid vapor equilibrium. Liquid vapor equilibrium. So this is for an ideal solution. Make an ideal right? Yeah, so this is total pressure. Above the total pressure, you have the liquid, right? Not the gas. If the pressure is higher than the total pressure, it is a liquid. If the pressure is lower than the total pressure, it's a gas. Likewise. Yeah. Right here, I am asking if AB is lower. I mean, when A and B is mixed, the amount of interactions are reduced. What is that? If the amount of interactions are reduced, they can easily attend to the vapor zone. They can easily attend to the vapor zone. That is negative deviation. Sorry, the positive deviation of Raoult's law. මොකද මේගොල්ලෝ මික්ස් කරාම ඉන්ටරැක්ෂන්ස් අඩුයි කියන්නේ ඒගොල්ලෝ ලේසියෙන්ම වේපර් zone එකට යනවා. ලික්විඩ් zone එකේ ඉන්න කැමති නැහැ. So when they are moving to the vapor zone, we can clearly understand the vapor pressure is getting increased than Raoult expected. If the vapor pressure is getting increased than Raoult expected, that is called a positive deviation of Raoult's law, right? The positive deviation. So then you can mark it, right? XA1 is XB0 is XB equal to 1, right? So this is P naught A, right? And this is P naught B. I'm getting the same variation to here. 7. So then positive deviation mark කරන්න කලින් ideal එක mark කරන්න. ඉතින් ideal එක. Then after mixing, if the amount of interactions are reduced, we know it's a positive deviation. So then mark the positive deviation like positively deviate. Like this. Here or no? Make it partial pressure of A, partial pressure of B, total pressure. Like it's positive deviation. So then we can get the boiling point variation of that. But you have to see the graph well. This is xb equal to 0, this is xb equal to 1. Right? Above xb equal to 1, we have to mark the boiling point of B, not A. So you can see the saturated vapor pressure of B is low. So we know saturated vapor pressure and boiling point, they have inverse relationship. So when the saturated vapor pressure is low, we say boiling point is high. So we can get this one as T naught B. Make a boiling point make it T naught A. So then this is higher. So we would say XB is XA equal to 0, is XA equal to 1. And then we can mark this. This is when it is ideal. So then when the vapor pressure get increased, we say boiling point get decreased than Raoult expected. Then the boiling point get added. Then Raoult expected. That's how the variation moves. Right? Variation moves. So then under physical chemistry, you can write equations unit-wise, and you can draw graphs like this. Right? I mean, when you are confirming the theories, you can do like this. Then after this, as an exercise, what I'm going to give you, try to make or try to edit, try to modify your organic, inorganic, general and physical short notes again and get a fresh start with this expansion, right? I mean, rescheduling the exam. So then try to get the theory parts again and again by watching our short note discussions. Then please attach to our WhatsApp groups. So then we'll be sending directly the short note discussions to your emails, right? So then you can just watch them freely and get a sound knowledge related to this. So then within this week, try to edit your short note and get ready. So then in the next week session, I'll be asking questions from you, right? I mean, random questions from you according to the short note discussion. So the next week session, I'm trying to revise, industrial, right? Industrial, general, and more physical questions, right? Question-based parts, especially overall discussion. So then, from by next week, we will be having 2 classes, Friday and Saturday, right? As usual. So then, try to attend to both classes and get a good revision related to the paper discussions, right? That's what I have to say. Then I have given the program. So then do join with us and then try to brush up your result, upgrade your result. We will be working really hard with you until you get the best results for chemistry. Okay. So thank you very much. I'm going to finish the session from here. Have a nice day.
Thank you, sir.